we will discuss 3 input logic gates. So we will see how 3 input logic gates are there. We will discuss symbols of logic gates and the relation between inputs and output, which is represented by boolean expressions. And finally, we will discuss the truth tables of all the 3 input logic gates. In this slide, we will discuss 3 input AND gate. When you say 3 input AND gate, means AND gate has 3 inputs and only one output. Symbol of AND gate: A, B, C. These 3 are the inputs and Y is output. Boolean expression of 3 input AND gate: Y is equal to A into B into C. Y is equal to A dot B dot C. So we can say in 3 input AND gate, it's a product of 3 input quantities. Truth table: inputs and output. This is a 3 input AND gate, so it has 3 inputs: A, B and C, and only one output, Y. Here we can see if any one input is a 0, then output of AND gate will be 0. So the mandatory requirement for AND gate is that all inputs should be 1, then your output will be 1. So if all 3 are 0, here output is 0. If 2 inputs are 0 and C is 1, then again output is 0. In the same way, if any one input is 0, then your output will be 0. So keep in mind, with AND gate, all inputs should be 1, then and then your output will be 1. Otherwise, output will be 0. 3 input OR gate. When you say 3 input OR gate has 3 inputs and 1 output. This is symbol of OR gate. It has 3 inputs: A, B and C, and 1 output, Y. Boolean expression of 3 input OR gate: Y is equal to A plus B plus C. So we can say this is addition of 3 input. So OR gate performs addition of 3 inputs. Truth table: OR gate has 3 inputs: A, B, C, and 1 output, Y, which is equal to A plus B plus C. When we say OR gate, in OR gate, if any one input is 1, then your output will be 1. If all inputs are 0, then your output will be 0. See, A is 0, B is 0 and C is 0. So output is 0. For second condition, 0, 0, 1. Here C is 1, so your output is 1. So we can say if any one input is 1, if one or more than one inputs are 1, then your output will be 1. If all inputs are 0, then your output will be 0. So condition is that if all 3 inputs are 0, then in case of OR gate, your output will be 0. Now we will see 3 input XOR gate. Symbol of XOR gate. See, this is symbol of XOR gate. It has 3 input: A, B and C, and 1 output. Boolean expression: Y is equal to A XOR B XOR C. Truth table: inputs. XOR gate has 3 input: A, B and C, 1 output. Y is equal to A XOR B XOR C. Now see, in this case, A 0, B is 0 and C is 0. So your output is 0. Here we can see B is 0, C is 1. So your output is 1. So in this case, if the odd 1 is there, then your output will be 1. If even number of 1s are there, then your output will be 0. See, here even number of 1s are there, so your output is 0. Here even number of 1s are there, hence output is 0. Again, here even number of 1s are there, so output is 0. Now see, A is 1, B is 1, C is 1, so your output is 1. So keep in mind, if odd number of 1s are there, then your output will be 1. If even number of 1s are there, then your output will be 0 in the case of 3 input XOR gate. Now we will see 3 input XNOR gate IC. This is negation of 3 input XOR gate. See, this is symbol of XNOR gate, and this is a combination of XOR plus NOT. It has 3 input A, B, C, and this bubble indicates NOR. NOT operation is boolean expression. Y is equal to A XOR B XOR C. So again, we can see here it's an inversion of XOR. So expression of XOR is A XOR B XOR C. Now we have just inverted due to this bubble. Truth table. Inputs. XNOR gate has 3 inputs A, B, and C, and output Y. Y is equal to A XOR B XOR C. Here we can see if A is 0, B is 0, C is 0, then output is 1. If A is 0, B is 0, then output is 1. So in this case, we can see if odd 1 is there in 3 inputs, then your output will be 0. If even number of 1s are there, then your output will be 1. So in this case, if 2 1s are there or even number of 1s are there, then your output will be 1. See here, A is 1, B is 1, C is 0. Number of 1s are even, so output is 1. In last case, A is 1, B is 1, C is 1. Here number of 1s are odd, hence output is 0. So we can say in a case of 3 input XNOR gate, if number of 1s are even, then your output will be 1. Here we can see 0, 1, 1. Number of 1s are even, hence output is 1. If number of 1s are odd, then output will be 0. In this slide, we will discuss 3 input NAND gate. 3 input NAND gate is a combination of AND gate and NOT gate. Symbol. This is a symbol of NAND gate. Here it has 3 input A, B, and C, and 1 output. Here bubble indicates NOT gate. NOT gate means we can say it's a AND plus NOT. Here boolean expression Y is equal to A dot B dot C, product of 3 inputs and its complement. Truth table. NAND gate has 3 inputs A, B, and C, and 1 output. Y is equal to A, B, C, and its complement. In this case, we can see all outputs are 1 if any one input is 0, and it will be 0 if all inputs are 1. So we can say it's a inversion of AND. In the case of AND, what was there? All inputs were 0, and if the inputs were A is 1, B is 1, then there in a case of AND, output was 1. So here is inverse of AND. Here if all inputs are 1, in this case output will be 0. So in case of NAND, see most of the inputs, we can say first in all inputs are 1, because in each and every case 0 is there, but in the last case there is not 0, so our output is 0. So in this case, A into B into C, 0 into 0 and 0 into 0, 0, and its complement will be 1. In this case, 0 into 0, 0, and 0 into 1, again it will be 0, and its complement of 0 is 1. In the same way, we can verify this truth table. Now we will see 3 input NOR gate. This is symbol of NOR gate. It has 3 input A, B, C, and bubble in front of OR gate, so it will become the NOR gate. Boolean expression, as we can see here, Y is equal to, as we know that for OR gate we do the addition of 3 inputs, so A plus B plus C, and for NOR we will take its complement. So complement of OR gate. In OR gate equation, Y is equal to A plus B plus C, and we are here only adding one complement of output of OR gate. Truth table. Here inputs, it has 3 input A, B, and C, 1 output. Expression of output is equal to A plus B plus C and its complement. So suppose we have input A, B, C, all three are 1, then 0 plus 0, 0, and 0 plus 0, it will be again 0, and its complement of 0, it's 1. So if we take second condition, 0, 0, 1, here 0 plus 0 is 0, and 0 plus 1 is 1, and complement of 1 is 0, so it will be 0. So in a case of 3 input NOR gate, output is 1 only when all inputs are 0. If any one input is 1, then your output will be 0.